Robert Hill's my name, and it's my pleasure to chair this next session, which is really, I guess, one of those where the rubber hits the road. It's zero carbon futures. We're looking at the directions, challenges and opportunities. We have four speakers. Deo Prasad, who's an academic, and I'll introduce to you more in just a moment, first speaker. Alan Jones from the City of Sydney, who I guess will give the practitioner's perspective. Dennis Else from Brookfield Multiplex, who will bring a business perspective to the issue, and David Schlossberg, who's going to deal with the politics. So we have a session that ends at 1 p.m. We'll have the four presentations. I hope there'll be a chance then for a few questions from the floor, and I'll sum up. The first of our speakers I just mentioned is Professor Deo Prasad, Director, Sustainable Development Program at the University of New South Wales. He's a Professor of the Built Environment, and he is the CEO of the new Cooperative Research Centre, Low Carbon Living. Deo.
Thank you, Robert. Okay, right slides are there. Thank you. It's good to be here. My talk addressing carbon issues, but one of the it's a broader talk, but one of the focus I come back to now and again is about the need for measurement and data that underpins good policy and planning decisions. And there has been a significant lack of all of that over time. Okay, it works. When you look at the urban environment, as we think we are trying to deal with a set of problems, the problems are forever changing. There's issues of globalization and urbanization, and as you know, it perhaps is not as obvious in places like Sydney, but you go to Asia-Pacific countries in particular, and you look at cities there, the rate of urbanization and the impact of that in terms of pollution and other factors is quite obvious in that sense. There are other demographic changes occurring all the time in terms of the mix, the disparity between people who can afford and who cannot, and age factors and others is constantly changing. And overlaid with that at the same time is climate change drivers, if you like. We are now becoming increasingly aware of the impact of climate change. And within cities, there's different numbers being thrown about, between 40 to 70% emission cut opportunities, reduction opportunities in the cities. And clearly there lies the biggest opportunities, depending on which research you look at, I suppose. But cities also have other aspirations. They are competing globally to make their urban areas attractive to live in, lifestyle issues, investment issues, they all come through that decision process. And the challenge is to maintain a balance, if you like, between the competitiveness issues for cities, the environment, the quality of life, if you like, and enough to attract investment within cities to underpin a lot of that. So you've seen a lot of triangulated sort of diagrams in the past, I guess, and this is yet another, with the competitiveness, environment, and quality of life balance being achieved, and governance being right at the middle of that. When you look at historically some of the drivers, if you like, in this climate change sort of environment and sustainability areas, go back a few decades and the oil crisis and how the impact of that down to design planning decisions was very much focused on reduction of oil imports and security type issues, very one single indicator focused, if you like. And that has had certain implications, if you like, in terms of how we plan cities for transportation options and buildings for low energy demand side efficiencies and the like. While we were grappling with that, this whole issue of environment and sustainability, the broader issue came about with broad range of indicators. We were becoming aware of the carrying capacity of the planet, if you like, and there were a whole range of issues that we were trying to grapple with in terms of tools, techniques, technologies needed to underpin all of that. While we are grappling with that still, this issue of climate change, one of those factors becomes much more obvious and important. And if we do not deal with that, as we hear from Copenhagen and beyond all the meetings, that 2 degrees C is the maximum beyond which the 450 parts per million, if we exceed that, there would be pretty noticeable difference in terms of what goes on, not only in cities, but elsewhere. So mitigation, adaptation, resilience, these sorts of terms are being used widely now. And how do we systematically, strategically, if you like, deal with some of these issues in terms of design, planning type decisions? We know a lot already, and others will talk about some of those. At the building level, if you like, we know a lot about demand-side efficiencies, the way we build here, different from other countries, and depending on climate, culture, practice, and all of those issues, there are tools, there are standards that have been in place, codes and things which were eliminating worst practice, some of them raising the bar slightly in terms of targets, if you like, but none of them really trying to reach zero carbon and beyond, if you like, in terms of the building designs. So a lot still needs to be done there, especially targeting high-end performance. Buildings are perhaps easier to deal with within a smaller boundary. As you increase the scale, if you like, to neighborhoods, broader cities and regions, a whole range of other issues, as you know, come about into the equation. And we need to look at the cross-cutting issues between urban energy, urban water issues, urban transport issues. A lot of these urban waste and health and well-being of the people in particular, how we can balance and create better cities while looking at the opportunities. So if you look at how we're moving towards a more decentralized energy, if you like, system, within cities where we have rooftop solar and a whole range of other options that are evolving, and water at the same time as well, waste treatment within urban environments as opposed to elsewhere. We are beginning to look at a whole range of differences in terms of how things were dealt with in the past and how we're trying to tackle them and how far we can go in this particular direction. Is the challenge we're facing. If we get the infrastructure and systems right, if you like, we will not make a big impact unless we have community on side. And that's one of the areas probably lesser regarded, if you like, in terms of what are the social change behavior models that work, which ones don't work, and why. What level of education, information needs are there that we need to deal with to take the community with us, if you like. So the three scales, if you like, have to be looked at together rather than very in a separate, disconnected way as it has been done in the past. We know about the high-end performance requirements being sort of coming about in Europe broadly, net zero energy, net zero carbon. These are code compliance type approaches, if you like, which is really raising the bar. Historically, we have used building code to just eliminate worst practice and other tools to just go a bit beyond that. But now we're trying to set requirements for much higher performance. If that comes about more broadly, if you like, to deliver the zero carbon that we are talking about, we need to be looking at a mix of these, and the implications of these on the community at the cold face of affordability, etc., needs to be much better understood. diagrams like this, McKinsey diagrams, have been, you're probably familiar with. It points towards buildings as being one of the better opportunity, negative cost, if you like, overall. But still we find that not much is being done. The industry take-up is very, very slow, even though there is a negative cost impact of a lot of the changes that we talk about. So there's a whole mix of issues, and community and people engagement is one of those issues. Of course, policy, etc., is at the center of that as well. When you look at a building scale, there's a lot, as I said, being done. There are buildings, and this particular one I put up there because I work in it at the University of New South Wales, 6-star new building, trying to generate as much of its own power needs, looking at daylighting and a whole lot of innovations that is becoming common knowledge now, trying to design and build with natural environments now in this particular city. But that raises the bar to a certain level, and it's way short of what we may call zero carbon or zero net energy type building. Look at another one here in Canada. It claims to be carbon positive, energy positive, and when you make these sorts of statements about any building or development, you clearly, the first thought that comes to your mind when you look at the building is, okay, I can see a lot of embedded carbon in there. So are they offsetting enough to pay back the debt that's already sitting there? Or is it just the operational life of the building they're talking about? How do you take these from one-offs to a mainstream, if you like, within society, so that everyone is trying to achieve or aspire to look at buildings which go so far towards zero carbon or zero net energy, if you like, which has now been shown to be achievable. When you look at products that enable that, rooftop solar type technologies, the rate at which the cost of these technologies are coming down now, it's about 15 to 20 cents per kilowatt hour, which is getting close to cost parity with grid electricity now. It's coming to a point where you might as well wrap your building around these because looking at the cost of electricity going up on the other hand, these will make good sense to have on your building, irrespective of the types of fluctuations in feed-in tariff that we have had in Sydney and elsewhere. So there are solutions which are not only functionally good but architecturally elegant as well, and these technologies are embedded into buildings to enhance their architecture and not just look at generating electrons from the facades. So a lot of these are becoming put out there to show that they can be made into elegant solutions, and upscaling them to community scale, for example. This is example in Japan, where a suburb-wide solution looking at taking them to zero carbon at residential scale. These are now beginning to happen, and there are solar city trials in Australia which are trying to test the logistics and all of that within Australian context. But here, if you look at a suburb at a time from an energy perspective, if they're heading towards zero carbon, that shows that the willingness and intent and technology and all of those things are evolving, if you like. There are some more grander examples, this particular one in Netherlands, for example, where from a green site, if you like, the whole development evolved with the basic notions of right to light and right to sun, so that they can utilize those when they design the buildings, if you like, in those developments, to a point where the whole suburb at a time is going zero carbon, and measurably so. One of the needs there is to be able to not only predict that they would be, but look at how they can be measured and demonstrated to be so. When you take it to the next level, like that, to the urban scale, the whole logistic issues, the interconnectivity with the grid, if you like, they become quite important. There's a level of intelligence being put into grid systems now, and they're being trialed in places like Newcastle and other cities around the world that are trialing a lot of the technologies where the grid talks to your house and optimizes demand so that the peak demand, which is a major problem, can be dealt with through good, intelligent system design, if you like, and going beyond that and looking at the need for, say, electric vehicles, the rate at which they come into mainstream, and how you can develop infrastructure to underpin a lot of those at the same time. When you look at some developments at the top end which are trialing these, things like places like Mazda, in a hot desert climate like that, but still aiming for zero waste, zero car, and zero carbon, if you like, type goals, whether they can measurably demonstrate that over time. Places like BedZ in UK, there's a lot of data. These are living laboratories from where we learn a lot about both the hard measurements in terms of carbon, at the same time community engagement models whereby we can test what works and what doesn't work with people who are actually going to be occupying them and living in them. And China, Tianjin type places are beginning to trial certain concepts in what they call eco-cities. There's 73 so-called eco-cities in China already, to different levels of uptake of technologies and techniques, if you like. The indicators there are being developed still to make sure that they can be measured and so that they become a knowledge base for the next generation of these developments. So the need for urban data, good quality urban data and models is very, very important. You would think by now we have nailed this area through good research, etc., but we find globally, whereas there are a number of good models out there, there's some disparate bits of data that exists around the country, even in Australia, that there is not publicly and widely available data upon which good planning and policy decision can be made, the evidence base underpinning these policy and planning decisions, if you like. When you look at not only new developments, but this is an example that you have probably seen the pictures of in Korea, where an existing development, a city situation on the top there, where they built more and more highways to meet the transport needs, and a green movement within 10 years of its construction was able to turn things around. And the bottom picture is what is there now after they got rid of the highways in there and activated the creek that was already hidden below those highways, if you like. So where there is good intent, you can, and just looking at them, you can see which one you would prefer having an apartment next to. So you can change what's existing into better places, if you like, if the will was there. Same thing applies to transport options. If you had the benefit of hindsight in planning in many, many cases, you perhaps would make different decisions about transport options, which seems to dominate the way urban form evolves over time. You'd very quickly start imagining what you would do with a transit-oriented development like that, and what else could, it could get people into cities walking and for good health and well-being, and all of those things can be tied to that if you had made the right decisions early in the piece. So those are issues, and there are a lot of opportunities out there. There's needs like urban data, urban models, new technologies, new materials, etc., that we are beginning to recognize that need to underpin a low-carbon future. It's all in the face of what we call a fragmented industry. Built environment globally is quite fragmented. Decisions are made in silos in different places, if you like, and that is another barrier, and there's a lot of inefficiencies because of that. So to take a positive note out of those and to enable these low-carbon futures to evolve, I think there needs to be some good research and development yet conducted that underpins a lot of these. And on a good note, we have a new Cooperative Research Center, which is a partnership between industry, government, and researchers now, looking at a lot of the problems and opportunities that I have flagged there. Over the next 7 years, hopefully, we are able to tackle a lot of these issues in a very large national center that's started within Sydney, headquartered in Sydney, but it's a national center. Thanks a lot.
Deo, you can sit up here. Well, thank you, Deo. Reminding us of the importance of decision-making on the basis of the best possible data, modelled in a way that it can be used to help assist make best decisions that lead to best outcomes. Our second speaker is Alan Jones, MBE, who's Chief Development Officer, Energy and Climate Change with the City of Sydney. Alan's maybe best known to you as previously Chief Executive Officer of the London Climate Change Agency, and for his work on that body in developing and implementing decentralised energy and renewable energy projects in London. I know his program here in Sydney is both innovative and ambitious, so please welcome Alan Jones.
Right, thank you for that. I'll start off with what the problem is from a City of Sydney perspective. This is a typical 1,000 megawatt coal-fired power station. It generates 1 million kilowatt hours of electricity per hour and more than 2 million kilowatt hours of heat per hour. That's a natural process of generating electricity from thermal means. That's rejected into the atmosphere using 5 million litres of water per hour. At the same time, more than 1,000 tonnes of carbon dioxide emissions are going up the chimney per hour. That's the picture for 1 hour. If you multiply that by the number of hours that you have in a year, 8,760 hours, you get the picture for 1 power station. You multiply that number of power stations you have in Australia, or indeed the world, and you begin to see where the real elephant in the room is. For the City of Sydney local government area, 80% of our emissions comes from this, coal-fired power stations. And that compares with transport, for example. So however much you think that is with clogged streets and all the buses and so on, that represents 8% of our emissions. This is 10 times worse than the transport. And the reason for that is that the grid efficiency across New South Wales as a whole is about 30%, and then further losses in the networks. The Hunter Valley power stations, for example, are 28% efficient, and another 8% of that is lost. So by the time it gets to the city, something like 25% of the primary energy burnt at the power station is actually used in the city. If you've still got those 100-watt tungsten light bulbs in your home, which is 10% light, 90% heat, you're down to 2 to 3% efficiency of the primary energy burnt at the power station. That's how inefficient we are. Now, all that inefficiency costs a lot of money, and we begin to see that in our electricity bills. In the current 5-year determination period, which the regulator has allowed the utilities to spend on network upgrades, something like $18 billion has been spent in New South Wales alone. $46 billion across Australia as a whole, significantly larger than the national broadband network that created such excitement in the last election. $11 billion of that New South Wales money is for peak power, primarily driven by electric air conditioning. At the beginning of the determination period, network charges were about 40% of electricity bills. They're now around about 56%, and next year they'll go up to 60%. So this is really a big elephant in the room of another elephant in the room, that most of your electricity now, or most of your electricity bill, is not actually electricity, but the poles and wires shifting those electrons from faraway places into where it is used. Another university, UTS, did some work on a modest amount of decentralised energy, would save $600 million a year, between $1.4 and $3.8 billion in capital investment, and between 2.2 and 8.4 million tonnes of greenhouse gas emissions. So Sydney consulted, it's the largest consultation ever in the city of Sydney, and 90% of respondents said they wanted urgent action on climate change. A key target, in order to keep within that 2 degrees centigrade, is a 70% reduction in greenhouse gas emissions. That's made up of a number of measures, but the principal ones is a 100% local energy system, made up of 70% tri-generation and 30% renewable energy. When I came onto the scene, all those targets and things had been decided by the city, and I was recruited from the UK, and they were quite honest. We've got a wonderful plan, but we don't know how to deliver it. So my role here is delivering that, and so one of the first things I did was to develop the Green Infrastructure Plan, which is made up of the 5 master plans: tri-generation, renewable energy, advanced waste treatment, decentralised water, and automated waste collection. I'll start with tri-generation. Same process, instead of using coal, using natural gas, so roughly half the carbon emissions of coal. And that heat is captured by its nature. It has to be where the load is, so it has to be in the city. It's no good out of the Hunter Valley. And that heat is captured, and that's used to provide heating and hot water. Through a further step, we can convert the hot water to chilled water using heat-fired absorption chillers. Now, tri-generation is not new in Australia. There's a number of examples, what I call boiler in the basement schemes, where small-scale systems are put in for a neighbour's rating or a Green Star rating or whatever. They're all minimised and downsized because of the regulatory barriers to decentralised energy that you have here in Australia, so that to avoid exporting electricity into the network. So they're not achieving anything like the big greenhouse gas reductions that are being achieved in Europe and the US and Asia. And so typically you'll get an 85% reduction in greenhouse gas emissions by connecting the city together in precincts. That's how it's done elsewhere around the world. We don't have individual systems in individual buildings. And that just gives you an example of that. Different time of day of use of both electricity, heat and cooling. And so it is a good thing to combine residential with non-residential because, you know, if you're not at home, where are you? You're at work or you're going shopping or you've gone to the leisure centre or whatever. And so energy follows people. And so if you connect different parts of the city together, you can get high levels of energy resiliency. A typical boiler in a basement scheme will probably deliver something like a 15% energy hit for that particular building. Precinct systems of the type I installed in Woking in London were typically 125 to 135%. The buildings were self-sufficient with between 25 and 35% available as export, which was not exported to the grid, but within the city. And in order to start from scratch in Sydney, needed to look at Sydney in a completely different way, or indeed any city in a completely different way. One of the first things we did, we brought Ausgrid, the electricity distribution network operator, and Gemina, the gas network operator, into the project team. And what I put to them was, because ordinarily network operators are opposed to these small-scale systems, but I just said to them, I'm not going to go at the small-scale level. I'm going to actually connect where you tell me to connect. Logically, electricity is coming from the Hunter Valley and being distributed on your high-voltage networks at your nodes. We'll connect to those nodes if you tell me where they are. And they did that exactly. This shows you the energy intensity for electricity in the city, and it's transformer data that actually shows where electricity is being consumed. The redder it is, the greater the intensity, which is predominantly electric air conditioning. We did the same thing with gas to work out the hot spots for heating and hot water. And combining those together, we back-calculated from electric air conditioning to work out how much chilled water was being produced and then how much heat we needed to actually produce that chilled water. So that gave us a picture of the energy-dense zones in the city. So these are the three energy-dense zones, CBD North, CBD South, and Pyrmont Broadway. We didn't assume we'd get all the city. We made an assumption of 65% commercial, 50% retail, and 33% or 30% residential. We've also captured Green Square in that, so collectively that comes to about 360 megawatts. However, it's displacing 540 megawatts from the grid because we're no longer using electricity for air conditioning or heating. And that gives you just a quick snapshot of where we are today and where we're heading to. In terms of economics, it's a $1 billion project, back calculated in NPV terms to about 440 million at today's cost. and it sits up and washes its face. It can actually do this economically. It is able to transfer surplus electricity through the distribution network outside of the national grid and outside of the very costly national electricity market. Just as a rain check, how are we doing on cost of carbon abatement? And as you'll see here, energy efficiency is the cheapest. We'd expect that, but you can't achieve a 70% reduction in emissions on energy efficiency alone. But decentralized energy is the next most cost-effective measure of reducing emissions. And you look right up there at carbon capture and sequestration, 4 times more expensive than decentralized energy. And so, yes, large-scale systems that we're seeing here, that's a heat-fired absorption chiller. If you've never seen one of those before, hot water comes in one end and chilled water comes out the other end. It's a static device. It has just a small, the only moving part is a small dilution pump. Some of my examples in the UK, this is one of my tri-generation stations in Woking, bolted onto the side of a multi-storey car park and supplying electricity, heat and cooling to the town centre. And again, one of my projects, London Olympics, so this is one of the 2 tri-generation stations that are at the London Olympics in Stratford City. Yes, thermal networks in the road. This is very new to Australia, but this is how major cities around the world get their energy. Copenhagen, for example, supplies 98% of its buildings across a 1,500-kilometre network, and Denmark as a whole gets 55% of its electricity from cogeneration and trigeneration, and 80% of its heat from cogeneration and trigeneration. And the reason it's a world leader in renewable energy is that its 22% renewable electricity from wind farms would be a lot smaller if we had to supply heating and cooling from that. So you do actually get to your renewable energy targets a lot quicker if you look at it in a different way. So on emissions, trying to represent what greenhouse gas emissions look like to people when you can't see the stuff, touch it, feel it, taste it. This shows you the height, shows you the annual emissions, and the redder it is the intensity, i.e. electric air conditioning. We've got one road building that's worse than everybody, but by and large, the CBD, not unexpectedly, very high emissions. We then looked at government targets, the 20% renewable energy target, and all those things that federal and state governments said they would do, and compared that with growth, and we found, best case scenario, there would be a 4% reduction in emissions. So that wasn't going to get us anywhere near our 70% reduction in emissions. However, decentralized energy network substantially reduces those emissions. Buildings connecting to the decentralized energy network will see their emissions reduced by between 40 and 60%. So that's with trigeneration, that's without trigeneration. Moving on to renewable energy, the trigeneration master plan is published, and the final one is currently out at the moment for consultation. That's been increased from 360 to 477 megawatts. Renewable energy master plan will come out in the new council cycle. So when I was given this task, the target was 30% renewable energy, but actually meant renewable electricity, because Australians think energy is electricity, and they're missing a trick there. And so this shows you where the renewable electricity resources are. The blue corridor is the kind of hot spots for onshore wind. The red areas, that's geothermal. Not really hot geothermal for generating electricity, but geothermal for putting in a thermal network, which is how we do it in Europe. You don't have to go down very far to get to 90-odd degrees centigrade, which is about what you run a thermal network for. So we're not looking for 250 degrees or something to run a power station on. The large things that look like suns, there's solar thermal concentration, and there's also a substantial offshore renewable energy resource around Australia, about 5 hotspots. One of those is between Newcastle and Wollongong for both offshore wind and marine technologies. So this showed us where renewable electricity was. If we captured all the resources that were available, we could deliver 55% within the LGA, but we still need another 45% outside the LGA. So we established a proximity principle. So we didn't want to invest or incentivize renewable energy miles away that just puts up people's network charges. So we've established a proximity principle for systems connected to the distribution network. I then included in that renewable gases. Now this is what's happening in Europe and the US. And we found that within 250 kilometres or less than that, there was enough renewable feedstocks out there from waste to actually replace all of the natural gas for the trigeneration system. It's a market that needs to be developed. At the moment, it costs people money to get rid of waste. This would actually turn it into an income generator. It's a combination of municipal waste, but the biggest element out there is agriculture and farming. There's a huge amount of waste that's currently being landfilled or burnt from the farming industry. Just here looking at cow and pig manure, 20% that would make up the energy supply for the city alone. The waste from broadacre crops, not energy crops, we're only looking at waste here. And this just gives you a picture of the untapped resource out there that's not currently being used. Not to generate electricity, but to convert it into a substitute natural gas for putting in the natural gas pipeline, because if you generate electricity at remote locations, you're only going to get 25, 30%. You pipe it into the city, you'll get about 85 to 90%. Renewable gases is actually more than just over half of what we actually need, and that would deliver something like a 31.5% reduction in greenhouse gas emissions. This is one of the advanced gasification technologies. This can convert almost anything into a renewable gas and reduce your waste going to landfill by 98%. Yes, only 2% going to landfill. And you can also recover water from waste as well using this technology. The three options down the side show that if you generate electricity locally at some remote location, you're not going to get more than 30%. If you pipeline it or if you convert it into liquid gases and move it to where energy is being consumed, you're going to get something like 80–85%. The decentralised water network, and we've literally published that plan this week, or will be after council resolution next week, for a citywide recycled water network. At the moment, this is what the City of Sydney looks like. Again, the higher that spikes are is the annual consumption, and the darker the blue is the intensity, primarily driven by air conditioning cooling towers, which account for something like 40% of water consumption in the CBD. That's what we hope it will be by 2030. How are we going to achieve that? By switching over from potable water to non-potable water for those services that we don't actually need drinking water for. And so something like 54 to 56% of water consumption can be provided from recycled water within the CBD. And we've also established we've got more than enough resources to actually deliver that. The consumption is on the left-hand side for the free catchments that we have in the city. And these are all the resources and the technologies available to us. We can actually now look at that from an economic point of view and pick the front runners. And for those, before you ask the question, the front runners are sewer mining, stormwater, and thermal desalination. So this gives you an overall picture of where the decentralised water master plan is taking us, and we're going to be similar to Trigeneration. We're going to use that as a procurement process to get citywide network put in by going out to the major players for that work. Automated waste collection. Very new to Australia. You have garbage trucks coming around, clanging and banging in the early hours of the morning. We all have to put up with that. But this was a technology developed in Sweden in the 1970s. And you don't have garbage trucks coming around. You have these receptacles on the street or in buildings. And the waste is evacuated underground at about 70 kilometres per hour. And that goes to a receiving station. Now, ordinarily, this would be a relatively expensive technology to implement. But if you're putting this in at the same time as Trigeneration, which has the economics, then you can retrofit recycled water and automated waste collection at the same time. And all you need is just a simple flatbed to come away and take the waste. There are about 80 systems operating worldwide. 80 cities around the world are using this system. And where they are using it, it reduces waste collection transport emissions by 90%. It's a substantial reduction in transport movements and emissions. But the biggest thing from residents in these cities has been the amenity. No one realised just how bad the amenity was until you took those garbage trucks away. You didn't have all them vehicles and bins out on the street, and all that all went away. That's the local government area. I'll quickly run through where we're at with our own projects. In the two and a bit years I've been here, the city's reduced emissions by 18%. Just let a contract for another 24% saving. That will be completed by the end of this year. That will take us up to 42% reduction in emissions, all achieved within 3 years. So I don't want to hear any excuse from anyone that say you can't do this. On top of that, we're also just let a contract to replace all of the streetlights, all the city-owned streetlights in the CBD or in the city with LEDs, and that will reduce our emissions and electricity consumption by 51% in street lighting. On Monday, we have a tender report that's been through committee already, that Council, if it resolves, will let a contract for the largest solar photovoltaics installation in Australia. Spread all over the city. You won't be able to walk around the city without seeing this stuff, and that's deliberate. That's the show by doing approach. And tri-generation, which I'll come on to a little bit more detail. We've signed heads of agreement back in As some of you know. We've, following a 2-year procurement process, we appointed Cogent Energy, that's owned by Origin Energy, the largest energy company in Australia, and we've already signed heads of agreements with those. Stages 1 and 2 comprise CBD North, CBD South, Green Square, Pyrmont Broadway, which is the area around Darling Harbour, and we've added a new one, Prince Alfred Park. The development agreement has been through committee this week and is due to go to Council on Monday for execution over the coming weeks. If you're going to do something like this, you need customers. So one of the things I did in London is that I had found that 20 landlords own 60% of the commercial real estate in the city. So no point in spreading your thin resources across thousands of owners and occupiers. You just target for the biggest. And this is essentially what we've done in Sydney. 13 or 14 major landlords own 60% of the commercial real estate. There's some universities in there, including Sydney University, I would add, and some big sort of state property as well. We've also was the first to implement environmental upgrade agreements, and the New South Wales version of that opens that up to all local authorities, not just to the capital city. This substantially reduces the financial exposure of anyone wanting to retrofit or put in new energy efficiency or water efficiency technologies. And again, this week we've put through the first application, $26.5 million environmental upgrade agreement to put in tri-generation and connect to the precinct system. And this substantially reduces the developer's exposure to the cost, simply the council taking that charge on the property can substantially reduce the interest that you would otherwise have to pay on a project like that. So these are the first couple of stages that I was just talking about. This is the Energy Centre or Green Infrastructure Centre at Green Square. So we've already signed up a number of developers already at Green Square. And that will house 12 megawatts of tri-generation, 3 4-megawatt systems, recycled water treatment and automated waste collection. So that will be, Green Square is the largest urban development in Australia. And so that will start out from day one as a green precinct. So if we're successful with all our master plan, bearing in mind we're already underway with some of our contracts, but we've still got a lot to do. We could see offshore wind farms off the coast of Sydney. And we could also see marine technologies. These are quite important because these are non-intermittent technologies, so they can compete head-to-head with power stations. As I said before, there is a significant resource for this between Wollongong and Newcastle, and Sydney's right in the middle of it. We'd expect to see every unshaded roof in the city clad with photovoltaics, and every building above 100 metres in height to have building integrated wind turbines of the type that we implemented in London. But if I could take you underneath the city for the minute as to what we call green infrastructure. Initially using natural gas, that gives us the economic construction of a decentralised energy network. But as part of our renewable energy master plan, to move over from natural gas to renewable gas, but using the natural gas pipeline. This will generate electricity. We will recover the heat from that electricity, and we will pipe that thermal energy under the streets to supply other buildings. The electricity will be making use of Ausgrid's public wires network, and we've been able to, as I explained before, been able to overcome those issues because we're going in at a larger level in the high voltage network, and we're not going to over-generate. It's just going to simply replace remote electrons with local electrons much more efficiently. And the energy network across the city will spread out both heating and cooling. I'll leave it there. Before anyone asks me any questions, all this information, council reports, tender specification, expressions of interest, all of that stuff that a local authority or anybody indeed can follow from beginning to end of how we've done this. That's freely available on this Power in Sydney website. Thank you.
Thank you, Alan. As I said, very ambitious. Our third speaker is Professor Dennis Else. Dennis is the Group General Manager, Sustainability and Safety, Brookfield Multiplex. He's also a Professor of Occupational Health and Safety at the University of Ballarat. Dennis will bring to us the business perspective.
Thank you very much, Chair. And it's great to be able to be here sort of presenting the business perspective, especially when I'm clearly not a business person. So I'm really an academic masquerading as a business person, and Brookfield Multiplex seems to sort of allow that. So I have a sort of joint appointment where part of my time is in the university world and part of my time is in the commercial world. And if I could just say that I've got a very sort of simple message, which really flows from the combination of Deo and Alan's presentations. I mean, it was clear from Deo's presentation that the built environment is the low-hanging fruit area in which we can get such a dramatic reduction in carbon for our nation. And I think Alan's presentation was a wonderful example of how thoughtful and coordinated action will enable us to achieve huge reductions in carbon for our nation. My simple message is that as we go down that path and make the most of this opportunity in terms of reducing carbon for the nation, I would like us to just recognise that this is also an opportunity to improve the performance of the built environment in all sorts of other ways. And that as we're doing a considerable amount of rethinking and refitting of our built environment, then there are opportunities which we can build in to get greater performance out of the space. And by getting greater performance out of the space, we often need to build less of it, or we can get greater returns on the volume of that space, which has long-term benefits to us, both environmentally and economically, and probably in a third way, socially. So if I could just sort of give a sense of where I'm coming from, I suppose the first thing is to recognise that Brookfield Multiplex is part of a Brookfield. It's a global asset manager. Brookfield owns large amounts of assets. You can see that the assets run through from sort of large amounts of renewable power, vast amounts of property, infrastructure, and Brookfield Multiplex, the bit that I'm involved with, is the construction part of that organisation across the globe. So we get involved heavily in the building of the built environment. We also do some various infrastructure work as well. And we're operating in sort of health, in retail, in sort of stadiums and other sort of activities like that. Engineering infrastructure, commercial space, residential space, and right the way through to sort of tourism and convention centres and so on, and justice and education, building of university buildings, such as the one that Deo was pointing to as an example of his own building, the Tyree building at the University of New South Wales. So we have a range of sort of leaders that are used to building the skylines of our sort of cities around the world, and they have a great deal of pride in the fact that they sort of create skylines. And so when showing them Alan's slides of skylines that were more high carbon skylines, and getting them to reconfigure in their head the skylines that they produce into, well, how much carbon production is that entailing, has been very interesting and very powerful. And I thank Alan for the opportunity of misusing those slides to influence them. And so they obviously have had a long history of green building, but as a result of sort of recent understandings of a greater depth, they really have shifted, and they've shifted the conversations that they are having with clients to one which is no longer just about the long-term value of the asset in economic terms, but moving to a triple bottom line conversation about the environmental value and the social value of an asset that is being built. And that doesn't mean to say that every conversation that one has with a client results in that client adopting the very lowest carbon outcomes that could possibly be achieved. But by having the conversation and taking the client on a journey of what is achievable, then it is possible to lay out the options in terms of three dimensions, in terms of the economic value, the environmental value, and the social value. And it's really up to the client then to make the decision of what works for them in terms of their decisions. But at least we can push our clients into understanding in a much longer life cycle view the decisions they're making, and ensure that they don't leave environmental value and social value on the table unwittingly. And you really can demonstrate to them the way of maximising their returns in a broader sense along the triple bottom line. So if I turn to the opportunities and sort of challenges, and I suppose whether they're opportunities or challenges doesn't really matter. There's only three that I'm going to go for, but the most important thing is that I believe that we really do need to capture that opportunity over the next few years of this search for low carbon, and ensure that we also turn it into an opportunity to increase the value that we're getting from the built space. So that's the convention centre in Melbourne, a 6-star sort of Green Star convention centre, I think the first in Australia. And what's most important about any of the buildings that we're producing surely has to be that they do what they're meant to do. There's no point in having sort of low carbon hospitals, we build hospitals, if they don't really heal people. So fundamentally what we've got to achieve is high performance of whatever the built environment is meant to achieve, and we've got to achieve that with a low carbon outcome. So for me, I'm a physicist by background, so I don't know if any of you saw the photograph on the front page of certainly The Age a few weeks back, was the ecstatic physicists on their world convention down at the Melbourne Convention Centre, and there they are, absolutely sort of eyes streaming with enjoyment because we found the Higgs boson, you know. And but the built environment has to be able to perform to actually be attractive to get all of the physicists around the world working in the field to come to Melbourne, you know. So whatever built environment we are dealing with, it has to be functionally a high-performing environment. And given that we're guests of the United States Studies Centre, I thought I ought to give credit to the way in which the work of Vivian Lofness just a few years ago really had an impact on our business, because what was very clear in her work was to distinguish between the sort of cost of energy per square metre, or she was putting it in sort of square feet, I think, and the cost of the people in the building, or the activity that goes on in the building. So in fact, the people are costing such sort of 20 or 40 times more than the energy cost that you're investing in the building. So therefore, if you're going to get value out of the building, small percentages in improving the productivity of those people can be hugely beneficial to you. And that has set us heading forward, looking at buildings very much in terms of their performance. And for instance, the study which we did with Deo's help of the Shelley Street Diagrid building, which is shown here, long-term studies to look at the perceived productivity changes as groups of people moved into that building. And we were lucky to have very financially minded client that was prepared to work with us closely on that, with Macquarie Bank. And they were able to show that we were getting something like a 15% improvement in the perceived productivity. We were getting dramatic reductions in sickness absence, a 20% less space used in the whole building. So that was significantly reduces your need for built space in the first place. 50% less energy, and for Macquarie Bank it was something like $100 million saving over 10 years. And so that's led us to very much follow the path of looking for where the evidence is. Other significant American researchers that are helping us with that, Esther Sternberg at a personal and sort of neurobiological level, looking at the way in which the built form increases the rate of healing of people in hospitals, so that now we can actually show why it is that certain designs of building will heal people faster. We're also, the research work showing retrofitting of buildings can result in lower stress levels for the people in the new space with greater light and other sort of green features to them. And that research has been added to with relationships we have with Frank Becker from Cornell University, so that we really do draw on the best evidence base of how we can get the highest performance out of space for individuals and for the way that people interact. So now, why am I going on about this so much? Well, if you can make the space perform better in the first place, you can need less space. If you need less space, that results in you needing less carbon investment. So, and as I say, if we come back to fundamental points that I was trying to emphasize, I think we need to turn on a sort of search for low carbon, but at the same time look for the opportunity to increase value from the built space, and that means the performance of it. And we also need to build and use the evidence base of low carbon, high performance built environments, and optimize the investments in low carbon built form, because we've really got to avoid sort of illusions of low carbon. Often people are drawn into going for sort of what appear in the short term to be benefits, but if you do the analysis over the long term, they may not be such good benefits. So it comes back in my mind to changing the nature of the conversation about built form, from one which is just an economic value to a discussion with our clients in terms of a triple bottom line, economic, environmental and social value. And that's where we tend to use this sustainable return on investment sort of model, in which we can have the conversation with clients as to how decisions that they make up front can have a very long-term impact for them in the running of their buildings, the performance that they're deriving from the activity in those buildings, but also the impact they then have further out in terms of economic and environmental and social value. And underpinning it all is the work that we've done over the years, just showing how important it is to get those decisions, or those discussions engaged early, because if we're trying to derive these benefits in low carbon and achieve high performance at the same time, the discussions have to take place very, very early, and in order to derive the benefits long term. Thank you very much.
Well, thank you very much, Dennis, and it leads quite well, I think, into our fourth speaker. I remember reading some work last year that was done on green schools, schools that were designed to improve their carbon outcomes, but in fact led to better educational outcomes and happier teachers. And I thought perhaps we'd got the politics wrong. Instead of trying to motivate people to demand climate change improvement, we should be using other opportunities that might have a more immediate reaction impact upon them than what we'd been advocating. And so our fourth speaker is going to address this issue of the politics. And he's very well qualified to do so. He's a professor, David Schlossberg, Professor of Government and International Relations here at the University of Sydney. His most recent work, I think, is as co-editor of the Oxford Handbook of Climate Change and Society. And he's currently co-authoring a book on the climate-challenged society. So, David? Tell us how we can make the politics work more effectively.
Actually, I'm not sure I can answer that particular question, but I do want to open by saying that I don't come to this from a planning background, and I don't even come to it from a traditional politics background. My background is in political theory, and most of my work is on environmental movements and environmental justice and social justice, and so what I'm doing is sort of the intersection of all of those. So I want to start with and talk about three real points today, or three political implications of the greening of cities. And the first really is what this means for, what it might mean about a real shift in the meaning of political organizing and the meaning for political organizing. I want to talk a little bit about what that might exemplify in terms of social and environmental justice. And then it was a nice segue, because I'll come back to a particular space where this kind of experimentation and training might take place at the universities. So here's the theoretical bit. One of the things that I'm starting to argue is that a focus on the greening of cities, the greening of towns, is a real part of a shift for environmental movement organizing from what folks in politics call a post-materialist approach to what a number of folks are starting to call sustainable materialism. Let me explain what the hell that means. So there's this idea that in post-scarcity societies and societies that are developed, in societies where we actually have most of our basic needs met, we develop a range of additional values beyond the material. We start to think about gender, we start to think about a variety of rights, we start to think about indigenous peoples, we start to think about identity and about sustainability. And the argument has been that in these post-material societies, that the public coordinates either non-governmental organizations, environmental organizations, political parties, that then put some pressure on the state, put some pressure on governments that then implement these policies. So it's not just that there are values in the public, but that those values then get translated into a number of different policies. That's the post-materialist idea, that once these basic needs are met, we go on to demand a range of things. Now, one of the things that we're seeing, of course, well, on the one hand, the GFC sort of shot a hole in that theory as people are going back to basic material demands and anti-austerity movements, but that's a little bit of a different argument. But I think one of the things that we're seeing with post-material concerns is a continued frustration or an increasing frustration and even a cynicism about the translation of these values into political practice. People are taught these values, they grow up with these practices, they're in our everyday discourse, but they're not really being implemented in the experience of everyday life for a lot of people. And so there's been a real growing frustration with the disconnect. And I think that's happened in a big way around climate change, especially around just the national governments in the global arena not really doing anything about the lowering of emissions. And there's this disconnect and this frustration. So the promise of post-materialism isn't just that people have these values, but they're getting implemented, and that's just not happening. So one of these post-material ideals, of course, and concerns is sustainability. And while a lot of people agree that this is a basic value, we see that the way that we're living, and movements see that the way that their lives are designed in an everyday way just isn't living up to that particular ideal. So there is a sense that bringing climate change, for example, and a variety of other environmental ills upon ourselves, the very construction of how we immerse ourselves in the natural world and how we provide for our basic needs isn't working. So generating energy, for example, entails massive outputs of carbon dioxide, pollutes the landscapes and rivers and air with various chemicals and gases, alters a climatic system that's been stable for the last 10,000 years. We get a sense that the working of our everyday life is problematic in some way. It's a symptom that our relationship with the environment as we provide one everyday need is dysfunctional and destructive. And that's just around energy. A lot of people are talking about the same sort of cycle when it comes to food, when it comes to the production of various accessories as well. Now, in response to that understanding of our material relationship, a lot of individuals and movements are moving to address their concerns through participation in some innovative and reconstructive responses. So what we're seeing is a lot more direct and immersive involvement in sustainable material processes, the development of local institutions of energy generation, of the flow of food. And it's a new form of materialism. It's a sustainable materialism. It's not just post-materialism. Foucault famously describes power as something that flows through people, and it's something that's reproduced in the practices of everyday life. It's not just a bureaucratic idea. It's something that we recreate in the actions of our everyday life. And what we're seeing is these sort of movements illustrating a resistance to participating in the flows of energy and the flows of food and other goods that they find problematic. And the flip side, a more reconstructive reproduction of practices that don't do so much damage to ecosystems or contribute to climate change. So people concerned about the flow of power don't just want to be off the grid. anymore. It's not this sort of 70s hippie, back to the land sort of stuff. People want to be the new grid. They want to actually have this power flow through them and embody it. It's really actually one of the reasons I like this idea of distributed power as opposed to centralized power and urban power generation. So that's what I mean by sustainable materialism, to remove oneself and one's community from these problematic and destructive flows of materials, and to replace unsustainable practices and forge alternative productive and sustainable institutions. And it's this kind of support that I think you see in a place like Sydney with the support for the city's efforts. Now, politically, I think the shift is illustrated in two important ways, both in terms of scale and in terms of focus. In scale, you really have seen a shift away, and in the US, it's been a physical movement of environmental organizations just shipping people away from Washington, D.C. And off to the states. They've been moving away from the national government as a target and back to the local areas. So that if there's a cynicism and just a lack of success at the national level, people are moving more into local and state politics. In the US, the big move, of course, was to California, to Massachusetts, some of the states, New York, where things were actually possible to get done. And that, in a way, gets to the shift not just in scale, but in focus. People who would traditionally be part of large environmental organizations, who would send checks off to large environmental organizations and just be happy to let them lobby and do their work, are starting to focus much less on that because of the lack of success and much more on, again, the practices of their everyday lives. And that's where we see this revived focus on everyday life happening. So rather than simply making a post-material demand that the government do more in terms of environmental policymaking or climate change beyond very simplistic or individualistic, cutting one's own energy use, we see a lot more collective focus on cities and communities developing, for example, renewable energy generation. And this is one of the slides I really like. This is San Francisco. One place, just one among many of those, San Francisco has a great map where you see this move. Right? San Francisco has a goal of moving to 100% renewable energy, very specific policies and incentives for efficiency in new building and retrofitting and adding solar capacity. And the idea is to lower the dependence, obviously, on carbon-based energy, but also to redesign and recreate various practices of local production. And what this means is citizen participation in physically becoming part of the flow of a new way of generating power. Now, clearly, there's state support for that, there's local support for that, there's all kinds of support, but the impetus for this is coming from homeowners, from renters, from builders, from individual companies, from nonprofits, from hospitals, from schools, a whole range of political actors who are interested in embodying their own environmental values and working with others to expand those citywide. And that's just San Francisco. That sort of immersion and distributed power is happening in a number of other cities. Now, the same sort of thing is happening around food. I mean, we're focusing on energy here, so I won't get into this very much, but it's the same sort of thing. So rather than buying industrialized agriculture from halfway across the globe, the idea is to be part of the growing, the selling, the sharing of food, community markets, backyard gardens, urban and rooftop gardens, and all of that. And again, some of that stuff is starting to happen here in Sydney. But the idea of food security or food justice here is not just a political demand, but it is a political practice of everyday life. And there's a whole other book there that I don't have time to get into. The second thing I want to talk about is the social justice and environmental justice aspect of that, because I think it's very important to note that this isn't just happening by or for or with wealthy communities. Yeah, there are plenty, yes, examples of rich individuals or companies or developers putting in all sorts of eco-amenities, but there's also a core concern for this, this sustainable everyday life idea in environmental justice organizations, in a number of green city plans. And there's a lot more about the greening of cities in environmental justice organizations. There's been a real shift in a number of environmental justice organizations from a focus on the inequitable distribution of environmental bads and goods to the inclusion of more vulnerable residents in the creation of just practices and alternatives. So in that San Francisco energy map, for example, you couldn't really see the differences in colors, but there are a number of dots that represent environmental justice projects. And these are projects that are either coordinated by environmental justice organizations or on the roof of low-income communities, but are also supported financially by the city. So it just is no cost for you to become part of that new grid. So you can have low-income communities being an integrated part of that new system. One example of this, it's from where I came from a couple of years ago, that I find striking. This sort of carbon transition is rural, but it is linked in some ways to the urban. So the Navajo Nation in the U.S. Is fully immersed in the carbon economy. It's also fully immersed in the nuclear economy, but again, that's a different issue. Coal mining is decimating traditional lands. The nation is home to the largest coal-fired and most polluting coal-fired power plant in Arizona. The nation also doesn't get much of that power. There are, I think about half the nation doesn't have electricity. So the Navajo are trying to move away from the damage done by uranium and coal mining and coal burning, which is another issue, by investing heavily in what they call a just transition. And the just transition includes solar, wind, and biofuel. And the connection here is that that just transition relies on the local communities, the ones they're surrounded by. The coal-fired power is bought by the utility, and the electricity is shipped very inefficiently, obviously, to LA, to Vegas, to Phoenix. But the Navajo are working with the local communities and the local universities to directly sell the solar and wind that they're generating and the biogas that they'll be developing straight back to the local communities like Flagstaff and around the Grand Canyon. So that's part of this sort of cooperative move to and just move to sustainable materialism. Now, a lot of other environmental justice organizations see this move to solar power generation and other city greening practices as sort of embodying another really crucial thing, and that's that they actually provide jobs. They provide green-collar jobs, as Van Jones famously laid out, crucial skills to the local population. This is a real key part to the Navajo just transition. It's also key to a number of other environmental justice-oriented projects. So this is a meshing of this sort of purely materialist development idea for basic needs, along with some of these sustainable materialism ideas. Green jobs is just a huge area of interest in environmental justice. Like I said, it's most broadly popularized by the work of Van Jones before he was kicked out of the Obama administration, but he's been picking that up as well. But you see a number of these green jobs as part of green jobs projects as part of environmental justice. So, for example, just one example, when I was at Princeton, right next door in Trenton, New Jersey, is an organization called ISLES. And ISLES takes unemployed youth, youth who are often unemployable because of their exposure to lead poisoning, which is a whole other issue, but takes youth, trains them, some in fairly low-skilled jobs, in putting in insulation or installing new windows or doors. They do some more training to do some solar and energy retrofits of community housing, and they do some large-scale building and renovation as well to teach kids more complex construction and renovation skills. Now, one of the interesting things here is that ISLES had been trying for 20 years to get rid of lead in public housing in Trenton, New Jersey. Trenton has a 17% lead poisoning rate, which is just inexcusable, and we'll leave it at that. But nobody would help them to replace the windows and doors that were creating most of the lead dust when they're talking about lead poisoning of African American youth. So they changed the discourse. Now they talk about efficiency. Right? Let's replace those windows not because it's harming kids and hurting the community, but because it's more energy efficient. And boom, the money flowed. The money flowed, and it helped these kids actually get the jobs they needed to renovate their own homes. But this is why the discourse is changing in a lot of environmental justice communities. If they're not getting what they need in one way, jobs for one, not getting poisoned for another. They're changing the discourse. So we see a lot of this, and Isles is a great organization, great example. They take these run-down vacant homes, not unlike you'd see in The Wire, and they completely renovate them, sell them to low-income residents from around the city, bring them in, develop urban gardens and foods, because of course there are no grocery stores around here either, so the flow of food is really crucial. They'll build gardens, establish farmers markets, so you get the renovation of an entire community. So again, the point is that there are environmental justice and social justice aspects to this. Isles defines their strategy as the 4 E's: energy, environment, equity, and employment. And again, food is another one of the aspects here. Environmental justice organizing has really focused on food justice in a number of communities. And some of it is in response to hunger, some of it is in response to the lack of availability of food, as I mentioned, the food deserts. Some of it is in response to the carbon outputs of industrialized agriculture, Dow. And a lot of it actually in the Native American communities has to do with the revitalization of traditional foods. So again, the point here is this link between a low-carbon future in the city, a concept of sustainable materialism, and social justice. And that link, I think, is at the heart of a number of initiatives. Last point. One key place this is happening, or can happen, and thanks again for the segue, one of the places where this intersection of sustainable materialism, social justice, and greening cities is happening is in the small laboratories we have scattered across the landscape in the form of universities. The sustainable city idea is being implemented on a small scale, a number of institutions, more in the US than here, though that's starting to grow here. And some of the most active are actually fairly large institutions that are cities in themselves. I think there are 2 fortuitous events here. One was the result of student activism, and that's something in the US called the President's Carbon Commitment. It was a commitment by university presidents to carbon neutrality by 2020. And there are actually 677 universities or colleges in the US that have signed on to this. It was a real sort of inadvertent stimulus for the development of a number of these. It helped that the presidents, when they first started this thing, had absolutely no idea what the hell it meant to go carbon neutral by 2020. It was only when folks on campuses started pointing out, well, you need to do this and this and this and this, that the presidents said, well, we're a little shocked at the amount of work that it was going to take, let's say. But it was student demand that actually pushed the universities in this direction. Now, part of that was that students, this gets to this idea of sustainable materialism, because students want to feel part of a campus community. They want their own values demonstrated in the everyday life of campus. And universities in the US now use these various aspects of the climate commitment to recruit and to retain students on campus. Now, these aren't necessarily students who want to be environmental studies or planning majors. My daughter's a great example. She's an English major, but she didn't want to go to a campus that didn't have something going on in terms of sustainability. It was something she grew up with, and she wanted to make sure there was organic food, there was something going on a campus. So the low-carbon campus now is considered some sort of amenity, along with fast web access and fancy apartments and all of that. But it's also where students learn to practice the things that they will take out of the university and into their urban lives. And it doesn't hurt that the universities are also saving a lot of money on their energy bills and food waste bills, for example. Now, one example of this, and it's difficult for me to talk about this because it was such a competitor in some ways, but Arizona State in Phoenix is probably the most visible and successful example. It's also one of the largest, America's university, as Michael Crow calls it, 75,000 students across the valley. They established a Research Institute of Global Sustainability in 2004, a School of Sustainability with a variety of academic programs by 2007. So yeah, they teach for careers in sustainability. You can get a BA, you can get a master's, you can get a PhD in sustainability. But it's crucial that the campus is also implementing practices that students are fully immersed in. And again, all students, not just those in the sustainability program. So they're generating already up to about 30% of their own energy use, and they're doing it in creative ways. This top picture, it's Phoenix, it's 45 degrees. So you don't like to park your car out in a black parking lot. So they built these shaded parking areas, but the shade is created by solar panels, so they're creating energy and keeping the cars cool at the same time. And then they're also doing a number of experiments with wind power right on campus, and very visibly. So students see this as they walk through the campus. They see all of this stuff. They're exposed to it every day. They're also decreasing solid waste, increasing recycling, water conservation, which is huge in a place that really shouldn't exist, as it sucks the water out of the Colorado. Colorado will have less, Colorado River, so it'll have less snowmelt as climate change increases. Phoenix is going to have even more trouble with water. So water conservation, sustainable food, planting and groundskeeping, purchasing, and of course new buildings. All the new buildings are what they call either gold or platinum LEED. And the goal is carbon neutrality by 2025. So even with all of that action, and it's one of the most active campuses in the States, they're still not going to meet the 2020 deadline. Now, the other really important point here is that they're developing and implementing projects in the local community. So they are involved with the Sustainable Cities Network. They work with communities and suburbs, including local Native American tribes. And so these practices that are developed at the university go out with the trained students into parts of the metro area. And the point here is that students are immersed in these new sustainable practices from the day they arrive on campus. And of course, they go out and demand these practices in the city, and they also become those that are employed in the larger Phoenix area. So I was going to talk a little bit about another way of doing this sort of thing on campus, this idea of action research teams, but I'll blow past that and just close again with a Foucauldian point and a sustainability point. It's not just about low carbon futures and about implementing social justice or even education for a sustainable century. Part of what this is all about is embodying an alternative that is a match for the circulation of power that is unsustainable in terms of energy, in terms of food, and a number of other practices. And I think the growth of the interest in and the growth of these practices and immersion in these practices is clearly expanding. The desire, I think, is expanding faster than the practices themselves. And to date, I think this shift has mostly escaped thorough political inquiry, and that's one other thing that needs to change as well. Thanks.
Well, thank you, David. I like the Phoenix example. I heard another one of floating photovoltaic sheets on water reservoirs. It reduces evaporation at the same time as it creates energy, and you've got nice, large, flat areas as well. Innovative solutions. Okay, we've got time for a few questions. Who wants to start? If you don't leap in, I'll leap in. Okay.
Thank you. Susan Thompson from the University of New South Wales, and I have the privilege of being with Deo Prasad on the CRC for Low Carbon Living. Thank you, gentlemen, for a very interesting panel. And I want to perhaps just ask for some comments to take maybe the discussion a little bit further about the ways that we can encourage people, particularly building on what you've said, David, incredibly eloquently, and thank you, around how can we take people further in taking on board this distributive power, taking the power into their own hands. One way that we're working on, I direct a thing called the Healthy Built Environments Program at the University of New South Wales. We're talking about the co-benefits of action on climate change for health and well-being. And when people can start to see that, hey, I can do these things for my child's health, my community's health, both physical and mental health, and it will also add to environmental sustainability. That sometimes is a bigger hook than perhaps the environmental sustainability. So I don't know, some comments perhaps.
Alan, why don't you have a go? Because I was wondering how do you motivate your community to give you the support you need, and whether, picking up Dennis's point, do you use arguments of improved productivity and the like?
I think if you follow the history of what I've done from Woking to London to Sydney, we coined a phrase right back in Woking, back in the early 90s, which is when we started that programme, of show by doing. And it's just a simple term, but that's what it's about. Local authorities need to lead from the front, large organisations need to lead from the front. And I think universities are very well placed to lead from the front, show by doing, and you've seen some examples here already. Don't underestimate the impact that can have on the everyday citizen, whether they're a resident of that location, or whether they're a visitor, or they just work in the city. One of the reasons we're rolling out PV all over the place is that we've got loads of buildings. We've got 230 buildings, and so we can put quite large systems. So rather than just concentrating on a single building, as a local authority, we can spread it right across the city. So you won't be able to go anywhere in a city without seeing this stuff. And I know from my experiences in both Woking and London, it makes people go back and do something in their own house. It makes people pressure their businesses that they work for. We start to see directors on boards pressuring what we're doing about reducing our carbon, what we're doing about this and that. And you've actually got to do something in order to incentivise other people to do it. And I think universities is very well placed for that because in addition to that, they've got education. Now, this is something that ought to be coming through in the mainstream in education. Even if it's running degree courses that have nothing to do with energy or the climate, it should still be coming through every degree that you're running in universities.
Show and do. Who's next? Yep.
Alan, in some ways, your presentation makes it sound quite easy, which I think is
it is
maybe misleading, but I'd like to get your opinion on that, because there's a lot of talk. We're here at a conference, we're talking a lot about it, but what you're talking about are some practical solutions. But I do have a couple of points. One is, to what extent is the density of the inner city make some of the projects much more possible and realisable? So if we were to commission you to do the metropolitan area, what would be some of the challenges which might arise if you were given that task? Perhaps related to that, what conversation are you having now with other inner city councils? Because it seems to me to make sense to leap beyond the city's boundaries at least. And then the third thing is, what are the effective barriers to a wider rollout of what you've been talking about? So what are those? And I suspect they're institutional more than anything, but so there's three elements to that.
Good questions.
I think my answer to your first question, there's no excuse and there's no hiding place. In Woking, which had a population of 100,000, it had an urban centre, but it was a very rural location. So we had isolated villages, if you like, not unlike what you see in Australia. And that's one of the reasons why I developed more than 80 decentralised energy systems. Yes, 80. And they were most of those were island systems, and they were supplying heating and electricity, typically a combination of cogeneration and solar electricity, which we found was the best fit for supplying those sorts of communities. And then we moved to London, and London, that's Greater London, so it's not just a bit in the middle like Sydney. It was Greater London, 7.5 million people. So that had a different sort of range of projects that actually mirrored what Greater London actually consumed. And then we moved to the city of Sydney, and yes, it's a relatively small local authority in the heart of metropolitan Sydney, but it's 25% of New South Wales GDP, 8% of Australia's GDP, and that is reflected in its energy consumption and in its emissions. And if you can't do this in Sydney, you can't do it anywhere in Australia. So Sydney had to be the place that you actually had to start here. It's doing things that make people happen. And I've been doing this now for about 20 odd years, and I've just seen through experience that doing things, people seeing things being done, makes people do things. Yes, there are barriers, institutional barriers, mindset, and I'm sure you're aware of that. You've got regulatory barriers over here. Stuff that could be removed at a stroke of a pen, wouldn't cost anything. You wouldn't need all them feed-in tariffs and grants and everything if you would just remove the regulatory barriers, because you're treating solar energy and these other forms of decentralised energy as if they were coal-fired power stations in the Hunter Valley. And the work that I did in the UK, which I got the regulatory barriers removed there, I actually did that with hard evidence. I actually commissioned people that knew how the electricity system worked. And we found, we looked at two sizes, 5 megawatt and 50 megawatt. And if we look at the 50 megawatt one, it costs $6 million to establish, to join the grid, and $2.5 million a year to operate it when you're only generating $1 million. That's what's wrong with national electricity market systems. They've failed. They've failed everyone. You've seen it in your electricity bill. 60% of your electricity bill is on poles and wires, shifting remote electrons from A to B. How stupid is that? If you went shopping at a supermarket that spent its proportion of money on shifting oranges from A to B, they'd be out of business. Why do we allow it? And, you know, the time has come to get rid of this sort of energy communism where you're forced to take everything, and that we should free up the system. We should enable cities to go independent. We should allow individual households, individual communities. People want to establish community wind farms, community solar fields. Why, you know, we're in a democracy. Why do you have a regulatory system that prevents them from doing that? And so I'm quite strong on this point. I got round the regulatory barriers in the UK by putting in more than 80 private wire networks. I wasn't supplying through the grid at all. And in London, the fear of doing that to London made people shift and remove the regulatory barriers and create a separate decentralised energy licence system, which was more in keeping with the value of what was being generated. And so I think my message is, by doing things, you make change.
Well,
I think what you're saying is incredible, because, you know, there's a big debate about increasing energy prices. No one knows why we're paying more energy prices, except, of course, the carbon tax is about to be blamed for it.
It's about 8% of it.
But it is
you're running up against a lot of embedded investment, aren't you?
Yeah.
A lot of vested interests. And
But the largest energy company in Australia has won this contract. That tells you something about efficiency and economics.
They're quite innovative, and I think they're looking a little out into the future.
So you need to be, no good being an
So
energy
what level
dinosaur.
of support have you had from both state and Commonwealth government?
Well, we have had some support from federal government. They've actually given us a couple of grants, and
No, not even grants. Are they true believers?
I think on the energy part of state government, for example, is a very big issue for them, because they're being battered all over the place with increasing electricity bills. And when I had a meeting with the Minister's office, you know, the thing he pointed to was not the emission savings, but the reduction in cost. That's where he wants to be. They've got to square the circle. They're getting a substantial income from profits on the network operators that they own. I think 25% I think they got, which is significantly more, I suspect, than Brookfield makes in a regulated monopoly. I mean, you know, it's crazy. But they know that if they carry on like that, it's just escalating electricity prices. It's becoming unaffordable for people. It's becoming unaffordable for businesses. Carbon tax is just a relatively tiny fraction. 60% of your electricity bill compared to 2.5% that you get with $23 a tonne. That's where we ought to be focusing. You know, centralised energy's had its day. It needs to be moved out and replaced by decentralised energy.
Okay, one more question from the left wing. Left wing is shy. Yes.
A question for Deo. Rod Simpson from the University of Sydney. We talk about low-hanging fruit, but it still seems to be out of reach. And my concern with the McKinsey analysis is always it doesn't take into account the time, the implementation to actually retrofit buildings or achieve those efficiencies. And as you quite rightly pointed out, Deo, business isn't actually doing that, taking advantage of that low-hanging fruit. And so it concerns me that we rely a little bit too heavily on that in our rather optimistic estimations of what we can achieve with that. Perhaps you'd like to comment on what the impediments you think are for business to take up those, or pick those low-hanging fruit off the low branches, because it's not actually a windfall.
I think when you look at where the numbers came from, that's largely based on the stock we have, stock of buildings now. I think the newer end of the market are taking on a lot of these, especially in the 6-star plus that you are beginning to see. They are taking up a lot of those, but not the existing stock from where a lot of those numbers comes from. I think that's what shows that to give incentives for the existing building owners to make the change, perhaps at the time of refurbishment they will capture it. It's not happening in a rush, not everyone's rushing to do it, but it will take much longer because of the existing building stock. I think that's where lies the problem. Yeah, I think perhaps every time you spend any bit of money, if you look at it as a positive cost, then that's the view. But on calculations in terms of paybacks and all of that taken into account, that's how it becomes negative.
Yeah, you're telling the fellow who's trying to sell apples at a negative cost if he converts to greater energy efficiency, but he's too busy selling apples. So there's lots of other factors involved in decision making in business. So can I thank the panel on your behalf? Low carbon future, it's a work in progress. Some of us sometimes get a little disillusioned, little down on what we think is so little progress being achieved, but you listen to these gentlemen and you realise there's actually extraordinary things that have happened in a very short period of time, and more extraordinary things that lie ahead. So thank you very much for contributing to our symposium. It's very much appreciated.